Okay, let me start with lecture number 4, and the title of this one is Complex Form of Fourier Series. Now in this chapter, the main thing is we try to express the Fourier series in the complex form. And we start with the so-called using Euler formula, which basically say e raised to the power ix is equal to cos of x plus I of sine x. So from that Euler formula, we can write out another similar formula which say e raised to the power minus ix is equal to uh, cosine of x and minus I sine of x. Okay, this is I and this is I. Now, so based on these two formulas, we come from Euler formula, we can see that if you take e to the power ix, which is this one, subtract e to the power minus x. If we subtract these two, then what we get will be equation 31, which is this equation right here. So basically, equation 31 says sine of x is equal to e raised to the power ix subtract e raised to the power minus ix divided by 2I. And this function here is an odd function. And the reason we say it's an odd function is because when we replace x with minus x, the answer is the negative of the other answer. So that's why this is the odd function. And similarly, if you add e raised to the power x from here, you add that with e to the power minus x, then we will get a formula for cosine of x. And again, this cosine of x is an even function. And the reason is because when we replace x with minus x, the function does not change the value. So, to summarize it, we got equation 31 and 32 based on the Euler relationship. Now let's take a look at the Fourier series. Look at the Fourier series. The Fourier series, if you recall from the previous lecture, it's any periodic function f of t is equal to a constant a naught plus summation of a constant ak times cosine of k omega naught t plus bk times sine of k omega naught t. But you can see from equation 32, we can replace cos of k omega naught t in terms of exponential. Okay? Like for example, if you look at equation 32 one more time, and if you substitute the value of x, like k omega naught t, if you replace x like k omega naught t, you also replace x by k omega naught t, then this term right here is exactly cos k omega naught t. So equation 33 again is exactly the Fourier series. The only difference is we replace cosine of the angle k omega naught t or sine of k omega naught t by some exponential form. So from that equation 33, what is the next thing we can do? we can say, all right, this term in here you have e raised to the power I k omega naught t. This term here you also have the same e raised to the power I k omega naught t. So if you factorize that term, then what you have left is here this remaining term, and then similarly if you factorize e raised to the power minus k omega naught t, which is this term in here, here you also have e raised to the power minus I k omega naught t. If you factorize that term in here, then the remaining term is right there, which is equation 34. So that is what we have for equation 34. The next step we'll do will be we define the constant A naught to be equal to a new notation C naught tilde, as shown in equation 35. Okay? And similarly, we also define the constant CK tilde to be defined as AK minus IBK over 2, as shown in equation 36. Now, we want to explain a little bit more about equation 36. Suppose you look at equation 36 and then you replace K with minus K. You replace K with minus K. And you replace K with minus K. And let's see what happened. What happening is, you can see in here, A with the subscript minus K is the same thing as A